The function g is defined for x greater than negative a half by g of x is equal to 3 over 2x plus 1. Show that g dashed x is always negative. So we can write g of x as being 3, 2x plus 1 to the negative 1. Or we could do it as a quotient if we want. And then that would be negative 3, 2x plus 1 to the negative 2, multiplied by the difference of what's inside. And that would give us negative 6, 2x plus 1 to the negative 2, which is negative 6 over 2x plus 1 squared. And so we can say that g dashed x is negative since 2x plus 1 squared is positive for x greater than negative a half. In fact, it's positive everywhere that x isn't equal to negative a half. So write down the range of the function g. So we know that it's not allowed to be negative a half, but if we did put negative a half in here, we'd have a 0 on the bottom. So that tells us that we have an asymptote at negative a half. And clearly it would be 3 divided by a positive number, so it's going to be up here. Remember, if x is more than negative a half, the bottom would be positive. 3 divided by a positive is positive. And as x tends to infinity, that's going to asymptote to 0. So we could say that it's real numbers, and we can say that y is greater than 0. So from 0 upwards. So the function h is defined for all real x by h of x is kx plus 3. We want to find an expression for h of g of x. So x comes in from this side, so that means that the function g is done first. And g is 3 over 2x plus 1, so that comes out of there. And then that's going to go into h. And whatever goes into h is multiplied by k, and then 3 is added. So that's going to give us 3k over 2x plus 1 plus 3. So we can say that hg of x is 3k over 2x plus 1 plus 3. And now we're given that hg of 0 is equal to 5. So 5 is equal to, substitute 0 into this, and we've got 3k plus 3. So 3k would be equal to 2, which implies k is equal to 2/3. Finally, we want to state the domain of h of g. And essentially, that's really only determined by g. This is a linear function, and so it has no problem with input. So it's going to be determined entirely by g. And so we're going to say that x is a real, and x is greater than negative a half.